Hello, in this video I'll be explaining how the ant behavior in my game Ant Keeping Simulator works. So I'll be basically explaining how the ants figure out where they want to go and what they're going to do and how they get there, stuff like that. And I'll be running you through the entire code that does that. Well, not the entire code, most of the code, the important code that does that. And hopefully that'll help you learn more about game dev. So this is very central to the game being good, so it's incredibly important. And it's also a pretty complicated thing to do. So it got several updates to the development. Like it started out much simpler than it is now. Basically, they're running around here. So let's just get into how it works. This might ruin the game for you, so spoilers. Basically, the ants have these pheromone points. So you see these lines, these white lines here. Those are basically pheromones, and the ants get one of the random pheromones assigned to them based on some more math, and that just sets where they're gonna go, and then they interact with that object, and then they either move it or stuff like that. They just interact with it when they get to it. And those pheromones are activated by sphere colliders on the objects of, like, say, these eggs here or something. If you want to make a game with lots of cool people and learn super quickly and to have a great time in general, go join the Discord in the description, and you'll learn way faster, and you'll make a game for charity. Super cool. We're doing it all as a big community, and then all the money we make goes to charity. So I'm making nothing off of this for the good of mankind. Now back to so all the colony code and this kind of stuff. It got a little bit bloated at the end. So like here we have three things. We're getting the active pheromones, then we're getting the food pheromones, then we're getting the dig pheromones. It is getting a little bit messy at this point. It's not the worst, but it's a little bloated. It's not too bad though. I'll explain more about the exact navigation system I used in the next video, because that's pretty complicated and I don't want to just brush past that. But for now, I'm just going to talk about the pheromone system mainly. And here we have the code that assigns the pheromones to the different ants. So it's divided into a colony controller and a worker ant controller. So all of these ants have like a unique worker ant controller. Not the best for performance, but I get more into how I optimize that later. So essentially here we have all these ants running around, and that is done by the worker ant controller, and the colony controller is the script that basically says where the ants are supposed to go. It also handles all the larvae and pupa and stuff like that. So and eggs, essentially just the brood of the colony. So here's how I assign the pheromones. So basically I go to every single worker. I check if the worker has a current target. So the target here is basically just a pheromone. And a pheromone is set up to be a struct here. So it just has, if it's active, what type of pheromone it is. So say it's like a food pheromone or a brood pheromone, stuff like that. That's stored in there. And then the position of where they're supposed to go when they have that pheromone assigned to them. And we check if the worker is replete. So basically there's these types of ants that store a whole bunch of food in their butts, and I don't want those to be moving around, so I don't give them pheromones. And I think I do some more stuff to make them move around, but basically those are relevant to this script, so I just check if it's not one of those. Then I check if we have more than one active pheromone, because otherwise we just have to make them roam. So roaming is just getting a random point on anywhere in where they can go. So basically a random point on the nav mesh, and which is a custom system for this game. It's not like the usual Unity nav mesh, if you're more familiar with that. I made a custom system so they can walk on the ceiling and stuff, because that's pretty important for ants. So essentially we either check if they meet the roaming chance. So if they either just randomly roam, or if there's no pheromones around, then they just roam around. If they otherwise, if they do choose a pheromone, then they check if a random number between 0 and 100 is less than 25. That's basically my way to decide it's basically my way to do probability in scripts. It's kind of nice. It's very readable, so that's why I like it. And if there's more than one food pheromone, or if there's one or more food pheromones, so greater than 0, then I just set that food pheromone to the target of that ant, and that tends to work pretty well. I do the same for digging pheromones, so that's for the digging DLC. That wasn't there before, but it's there now. So this is basically just the same thing as the food thing, but for digging. Just if a random chance, assign a food pheromone. So this is basically there because otherwise they just wouldn't eat enough, because there was too much focus on caring for the brood and not for the food. So this is just a very basic forehead way of me just making them focus more on getting food, just prioritize that basically. If they're out of food, they'll all roam. So this is just the same code here as and that is if they just randomly roam usually. But if they don't have any food, then they roam because they don't have food, and then they stress out, and then they just go look for food. That's also just so if you have the time speed set very high and your nest is a little too big, then they don't they don't forget that there's food, basically. So that's just a little way to make sure they don't run out of food when there is actual food to eat. And lastly, if we don't select like a specific pheromone, we just get an active pheromone for them to interact with. So these pheromones get deactivated when they get assigned. So new pheromone here basically starts a coroutine to deactivate the pheromone again, and that just makes sure that they don't stick around forever. And that's why we here have to check if the pheromone is actually active, because otherwise they're just going to go to all pheromones, and that doesn't really work. So this isn't the most efficient way to do this code, but it doesn't impact performance, so it's fine. But usually, if you're doing something like this in update, you wouldn't want to use where. You would want to create a for loop or something, because I think that's actually much more efficient, like code and memory usage wise, than doing it this way. This game isn't that performance sensitive either. Like it kind of is, but it also kind of isn't, because the ants are already using so much performance that it doesn't really matter that much where little bits of performance are costing. Just because navigation is complicated, and I'm sometimes running like 10,000 ants, so that's, performance issues just will arise if you're running that many ants. So, and then here we have the final little bit for leafcutter ants that just makes sure that the tiny leafcutter ants don't leave the nest, which is just a specific thing with that species. So let's get into how the actual ant then gets to where they're going. First, we have this performance thing. So I said that the ants take quite a lot of performance. So basically, I just check if the ant count, so basically just the amount of ants we have, is greater than a certain number. If it is, then I set the delta, so basically the time between frames, between like updating the ants. I just set that to a random number between some number and some other number. That just makes sure that they're updating less often than usual. And that's like kind of gradual, as you can see here. Just a whole bunch of if statements, pretty basic. And I do the same with the audio, because otherwise you just get like 25,000 audio sources, and that kind of causes performance issues at some point, so I have to disable it in the same way, basically. Or slightly differently, I just use a random number. But so my point was, here is where that starts. We have here a little thing to increase performance slightly, where we only update like the LOD system and the chunk that the ants are in every 2 cycles of the script instead of every cycle, because that's just slightly more efficient. Here we do some baby carrying code. So there's a specific navigation section for carrying a baby, and or like anything else really, but it's just called carry baby still. Oops. I should probably refactor that, but it's currently fine because I'm the only person working on this code. So I just know that that's what that means. And then we just continue. So we just basically restart the loop there. And here we get into the actual like locomotion area. So we just check if we actually have a pheromone at that time. And we check if we're hunting. So like this just avoids us triggering this when some other code should be running. And then we basically just start this coroutine here. This coroutine handles our navigation. It's pretty long and it's a little bit complicated. So I'm not going to explain all of it, but essentially we do some finagling here to make sure that we don't call all our navigation code. So basically I do something here to limit how many path calculations we can do in one frame. So that just avoids lag spikes and spreads out the load a little bit. And also just limits how many path calculations we can have at all. So at some point ants just start standing still, which is fine because you get, at that point you have so many ants that it doesn't really affect anything anymore. So basically, this is also affected by performance settings, so that's just something I wanted to note. But yeah, so basically we skip this sometimes, but we don't always. And if we do skip it, then nothing happens basically. If we don't skip it, we do this calculation here using our custom nav controller, and we just get a path from that. Now that gets a path again from all the sections of the